What's up, everybody? Welcome back to yet another episode of Basic Chemistry 101 with Sihlebonani. My name is Sihlebonani, and today, as you can see, we've got an unbalanced equation. It means we have to balance it. And this is how it looks like when it's balanced. I hope you can see. But if you don't, let's see how do we balance equations. Let's go.
Let's go. This is for every child that wants to make it one day. Izimbo class and presence of mind is elsewhere. Bring out Uzuzani, I've not moved already Aliswani and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, lay the reason and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, help me.
So today we are doing balancing chemical equations. What are chemical equations? So a chemical equation basically is a symbolic representation of a chemical reaction. That is a chemical equation. An example would be if you are reacting chlorine gas with the sodium metal. When they react, they're gonna form sodium chloride, and that is a salt. So for someone to understand what is happening, you're gonna need a chemical equation. Now for a chemical equation to occur, or for a chemical equation to be written correctly, you have to know the reacting chemicals and the products that they form. So if there is sodium, which is Na plus, your chlorine gas to give you sodium chloride, these are your reacting species, which is your reactants. And then this one would be your product. And then this arrow would represent these two react to form that one. Sometimes in your chemical reactions, there would be conditions that are put together. For instance, sometimes you would burn, which is your combustion. If there is a presence of heat, we would write this delta sign here. If there is a catalyst, we would write, let's say, sometimes the catalyst would be platinum. So you would write your platinum there, and other chemical reagents that are used for the reaction to occur. So that is how a chemical reaction is actually written. But you will find that when we're speaking about atomic theory, we spoke of a chemical reaction being a rearrangement of atoms. And that's dealt in, and also the law of conservation of mass. So if a chemical reaction is basically a rearrangement of atoms, it means what is on the reactants must be equal to what is on the product side. So if you can see you have two molecules of chlorine, but there you have one. So for you to write a chemical equation, these need to be balanced. So I put a coefficient next to my substance there. I can manipulate the subscripts. For them to balance these equations, I have to use the system of putting coefficients next to each compound. But now, since I've put this coefficient here, it means it multiplies everything that's here, and this is 2 sodiums now, and here I have 1. So this means I must put a 2 next to sodium so that I can have a balanced equation. So that is how we would write your balanced equations, or that is how you would write your chemical equation. You have to balance what is on the reactant side with what is on the product side. Let's move on to some examples. Now imagine you are burning propane and oxygen. You would get carbon dioxide and water. Now you would want to balance each atom on the reactant side with each atom on the product side. So in this equation you have carbon, you have hydrogen, you have oxygen, both sides. Now there must be an equal number of hydrogens, carbons and oxygens on both sides. So if we look at this equation particularly, find that you have 3 carbons, you have 1. So we can balance that and put a 3 next to carbon. But now, if this is, then here you have 8 hydrogens and then you have 2 this side. So we can put 4 here. And then we have 6 oxygen, 6 plus 4, you have 10 oxygens, and here you have 2, so it means we'll have to add 5 oxygens to this side. Once we have added 5 oxygens, we can count each atom this side and compare it with the same atom that side. Then you find that your atoms are balanced on both sides. Now this is called balancing by inspection. You just look and try to make them balance. But what if there was an easier way to do that? Let's try and look for it. Let's look at this equation. Now, for us to make things easier for us, you always, let's do it like this. You always look for an atom which occurs once in one substance, both sides, of which, in this case, each atom occurs once in one substance, both sides. So this one would be easier. So you can look at P, it occurs once this side, it occurs once that side, which is your phosphorus. So there's no need to change this one. Then you look at nitrogen twice, but when you look at oxygen, here there's 6 oxygens, there's 1. So we will add this one, and then this changes the dynamics of here, and then we'll also add another 6 there. That one is fairly easy. Let's look at this equation as another example. You look for one atom which occurs once on one substance, both sides. So see, hydrogen occurs once this side, but hydrogen occurs twice this side. So we can't look for hydrogen because it's going to give us problems. Then you can look for chlorine because it occurs once here and it occurs once this side. But you have 5 this side, you have 1 there. So this will be 5 number of chlorines. Then if this is 5, as for oxygen, because now we are done with chlorine, we are done with phosphorus, it occurs once and it's 1. Now we can look at oxygen because it occurs once once this side. You have 4 oxygens, you have 1 here. Then this will give you 4 this side. Then you will have 8 hydrogens and you'll have 8 hydrogens that side. So they have balanced themselves while we did this. This is our last equation, and the rule, you look for an atom that occurs once on both sides, which is in this case oxygen. We can't look for it, but we can look for phosphorus, we can look for hydrogen. I'd say let's look for hydrogen first. Find that you have 2 hydrogens here, you have 3 here. So for these to balance, you would write the 3 here, then you write the 2 this side. Then you find that here you have 3, here you have 3, here you have 13 oxygens. Here you have 13 oxygens, and here you have 8 oxygens. So I want to have 13, 13, or I want to have 8, 8. But if now this becomes tricky, but you'd find that if you have 1 phosphorus, you have 2 here. Then if we reduce this and make it a half, it means you have 2 phosphorus, then 5 oxygens. 5 oxygens plus 3 oxygens gives us 8. So that is how I would balance this type of an equation using that rule that we're talking about, which is you look for an atom which occurs once on both sides, and we have balanced our equations. So what you need to do is practice a little bit more, and once you get to know it will make things easier when you move forward in calculating your calculations that are based on chemical equations. I hope that is something that you can understand. I hope that moving forward you won't have so much difficulty in balancing equations, because everything else, it revolves around a balanced equation. Thank you very much for watching. This has been Basic Chemistry 101 with Sitlebonan. Please subscribe, please share, and like if you did like the video. Even if you didn't, thank you very much. See you in the next one. Booyaka!